IXL goes over IXL T3, and this is HHP. So this is graphing inequalities. So in the past, you've learned how to put them in slope-intercept form, and now we're going to graph them. So it says graph this inequality. So when you have something like this, I'm not drawing. When you have something like y equals -6, the thing that's missing here is our mx, which just means it's 0. But this is actually still our y-intercept. So our y-intercept here is -6. So we're going to put a dot there. The next thing that we are going to do is we don't have a slope. So when we don't have a slope, that means that no matter what value, our y has to equal -6. So it's a straight across line like this. So no matter on this thing, y has to equal -6. All right? So we have our line. A couple things with an inequality that you need to know. If you have things like this, if there's a line underneath the inequality, that's a solid line on the graph. If there is not a line under the inequality, that is a dotted line. So I went ahead and did a solid line, but it's not supposed to be a solid line because there's not a solid line under my inequality. It's right here. So that means that this is supposed to be dashed, and you can select dashed in IXL. You just click the line again. It'll change it back and forth from dashed or dotted to solid. And then the last thing now we need to do is shade. So to look at the shading, how we figure that out is if you have these symbols, which are greater than, that means you shade above the line. And if you have these cute little ones that look like squished L's, L's mean below the line. So if I'm shading below, that means I'm shading all down there. Okay, let's do another one. This one isn't just in a y equals form. This one actually isn't in slope-intercept form at all. We not only have to do that, then we have to graph it. All right, so from the past examples we've learned, which is the previous IXL, you've learned how to do this, which is move x first. So I need to subtract this 5x from both sides. And I'm going to bring down my y greater than. Now I'm going to write this as -4x plus -4, -5x plus -4. If you wrote it backwards, you can flip it in another step. I just wanted to skip a step. All right, I don't have to divide anything in front of y because it's just, there's nothing in front of y other than just a solid 1. So now I can use this information. So this -4 is where I begin, that's my b. And this -5, this is my slope or my m. Okay, but -5 just needs to be over a fraction. So we're gonna make it -5 over 1. That's my m, which all I did was just put it over 1. So that's my m. So in order to graph it, I need to begin at -4. And to remember where on this graph is -4, you always start on the y-axis. And I always kind of think about it because like to draw the letter B, you have to go up and down first. Like you have to draw a downward line. So we're going to put B at -4. Then we're going to use our tools to move using our movement, which is -5 over 1. So that's down 5 over 1. So from the dot we just created, we're going down 1, 2, 3, 4, and 5, and then over 1. And that's where we're going to get our dot. That's our second dot. Look at us. So once you have 2 dots, you can go ahead and just draw a straight line. So let me get that for you because I can't draw a line. Oops. Shapes. Draw. There we go. Oops. Here is my line that I'm going to draw. Oops, not really right. So I drew my line. IXL connects them for you. They're super nice that way. So now I have to ask myself, is it dotted or solid? Well, I did mess up because I did it again. There's no line under this inequality, which means this is supposed to be a dashed line. So let's try this again. Let me see if I can fix it. Let me see if I can fix it. There we go. Now it's nice and pretty and dashed. Now I have to look. Now do I shade above or below? So according to this symbol is the greater than symbol. So greater than means above. So above the line is over here. You can always triple check your answer by plugging in any point that's shaded. You can plug it in here to make sure it's true. So for example, this point right here, this is 0, 0. It's in the shaded area. So it should work. So if I did the 0, 0, this is my x, this is my y. So if I did 5, instead of 5x, I did 5, 0 plus, instead of y, I'm also going to put 0 is greater than -4. 5 times 0 is 0, plus 0 is just all zeros, is 0 greater than -4. If that is a true statement, then we shaded the correct side of the line. So we did good.